In this video, we are going to do an example of a log equation. Now, when we're solving equations with logarithms in it, in general, the steps that you want to take is first, combine logs into one log expression. And you're going to do that using your properties of logarithms. Once you combine all your logs into one log expression, the next step is you want to change from log form into exponential form. Then, once you get it in exponential form, you get it in a form where you can solve for x. And then the last step is once you figure out what x is, remember you could have some extraneous solutions here because you cannot take the log of 0 and you cannot take the log of a negative number. So you want to make sure when you solve it for x, those values of x, when you plug it back in, doesn't create that problem of taking the log of 0 or taking the log of a negative number. So with logs, you want to make sure you check your answer. Okay, so in this equation, we have two log expressions, and they're separated by a minus. So that means we have to change this into a division problem with one log using our rules for logarithms. So I'm going to rewrite this as log, and then in the numerator, it's x plus 5, and in the denominator, it's x plus 2. So now I rewrote this using one log expression. So now that I have it in with one log expression and it's all condensed, now we're going to change it into exponential form. Now, even though it doesn't say it here, we know that if there's no base listed, we're going to assume that it's the common log, which is base 10. So to put this into log form, I'm going to take 10 to the second power is equal to x plus 5 over x plus 2. So then I get 100 is equal to x plus 5 over x plus 2. So now I have to solve that for x. So I'm going to cross multiply, or you can clear the fractions, whichever way you prefer to do it. You'll end up with the same thing. If I cross multiply, I'm going to get 100 times x plus 2, which gives me 100x plus 200 is equal to x plus 5. Now, when I solve this for x, I'm going to subtract x from both sides and subtract 200 from both sides. So that's going to give me minus 195. And when I solve that, I get 195 over 99. And let's see if we can reduce that. Yep, when we reduce that, we would get negative 65 over 33. Okay, so now here is what I call at this point a possible solution. Because we still have to check to make sure if we plug it back in, it's going to work. Because remember, we can't take the log of a negative number and we can't take the log of 0. Now, negative 65 over 33 gives us as a decimal something that's a little bit less than negative 2. Or actually, that would be a little bit bigger than negative 2 because it's about negative 1.97. So if I plug in approximately negative 1.97 in for x, that's not going to create a problem for me as far as taking the log of a negative number. And it's definitely not going to cause me to take the log of 0. And then you can actually plug it in to make sure that it works, like the whole thing, and plug in negative 65 over 33 into the original equation and make sure you get 2. Just make sure you use the common log on your calculator to do that. So this would be our final answer if we want it in exact form. as an approximation, we can say that it's about negative 1.97.